Okay, so now we're going to graph this guy. Our first step, what we're supposed to do is factor top and bottom. So I could factor, say, a 2 out of the top. X squared minus 25. Hey, that's a difference of squares. I could factor that again. 2, x minus 5, x plus 5. And then the bottom, that's x plus 5, x plus 3. Okay, so we factor top and bottom. We check and see if anything cancels. Hey, I have a common factor. Notice I cannot cancel these x squareds. You can only cancel factors, not terms. So you must factor first. Factor top and bottom. X plus 5's cancel. I get 2x minus 5 over x plus 3. But that equal sign that I just wrote is not really true. These two things are only equal if I did not just divide by 0. You're not allowed to cancel out a 0. So who was the bad guy? Who would make this guy that I just canceled out 0? That would be negative 5. So x is not allowed to be negative 5. That means that I'm going to have a hole at negative 5. Instead of a vertical asymptote. Now I just graph what's left over. I graph this thing, and then at the end I add the hole. Okay, so it's the same process. I find my domain. Domain is anybody that makes the bottom 0 is bad. I've already found one, negative 5. X is not allowed to be negative 5. I can just glance and see who the other one is. Negative 3. I have two bad guys. It was a quadratic. Quadratics always have two solutions. I have two bad guys. So my domain is negative infinity to negative 5, negative 5 to negative 3, and negative 3 to infinity. 3 sections of domain. Okay. Find a vertical asymptotes. We do that by setting the bottom equal to 0, but only in the reduced version. So I had two bad guys. That guy's not a vertical asymptote. He's just going to be a hole because he canceled out top and bottom. It's this guy that's left over that's a vertical asymptote. So the only vertical asymptote I have is x equals 3. Horizontal asymptote. Look at the degrees, top and bottom. I can go here to the original or to this reduced version. Doesn't matter. They have the same degree. They're both x squared. Or here, they have the same degree. They're both a power of 1. So I take y equals the ratio of leading coefficients, 2 over 1, which is just y equals 2. Here's my horizontal asymptote. Let's put that stuff on the graph. So I get x equals 3 was the vertical. Y equals 2. Is that what I got? Yep, y equals 2 is the horizontal. Okay, I find intercepts. X-intercepts. Set the top. I could use either version, but I got to remember I'm not allowed to use negative 5, so let's do everything with the reduced version. Set the top equal to 0 and solve. That 2's not doing anything there. I could just divide out the 2. 0 divided by anything is 0. I get x minus 5 equals 0, x equals 5. So my x-intercept is the point 5, 0. That 5 has nothing to do with that 5. The only reason we got 5s floating all over the place is we had a difference of squares. X squared minus 25. So don't let this 5 and that 5 get you confused. They're not related. Y-intercept. we plug in 0. So I'll get k of 0 is 2. 0 minus 5 is negative 5 over 0 plus 3 is 3. I think that's negative 10 thirds. 0, negative 10 thirds. Let's take this information, put it on my graph. X-intercept 5, 0. That was 3, 4, 5. 5, 0. Y-intercept was 0, negative 10 thirds. So over 0, negative 10 thirds is a little more than negative 3. So right there. Okay, we check and see if we cross the horizontal asymptote. That's a yes or no question. The answer is usually no. In fact, here's a little hint. Anytime your function is linear over linear, the answer is always no. You're never going to cross the horizontal asymptote. But let's check it just for fun. I set the function equal to the horizontal asymptote. So that's the function. That is the horizontal asymptote. And I try to solve. That's a proportion. We solve proportions by cross multiplying. So I'll get 2x minus 5 equals 2 times x plus 3. Just multiplying the x plus 3 over. Distribute. 2x minus 10 equals 2x plus 6. Hey, those two x's cancel. I get negative 10 equals 6. No, it doesn't. Negative 10 does not equal 6. What does that mean? It means the answer then is no. We do not cross. That's all I needed. I can now graph. Almost. I'm going to have to plot the whole. Okay, over here in section 1, in this half of the graph. The graph can't possibly live up here because I've already got a point down here. Is that point right? And see, these graphs are self-correcting because I just realized, looking here, if my graph lives like this, right here, something's not right because I would be crossing over the x-axis. There would be an x-intercept here. Something's not right. Something must be wrong with this graph because this point must be on the graph. If I graph like this, I would have an x-intercept there, and I don't have one. So I paused the video and I went back and looked and realized that right here, the vertical asymptote was not at 3, it was at negative 3. These graphs are self-correcting. If you make a mistake, things will not line up. So this was not my vertical asymptote. In fact, maybe I'll just get a brand new sheet of paper. My vertical asymptote was at negative 3. X equals negative 3. My horizontal asymptote was at 2. My x-intercept was 5, 0. My y-intercept was 0, negative 10 thirds. It's a little more than negative 3. Okay, now this is correct. Now, my graph over here in this section must look like this. It's got to hug both of these asymptotes. It has to pass through the points that I already have. Back here in this section, the graph cannot possibly live underneath because if it did, there would be an x-intercept right there, and there's not. The only possibility is that the graph lives up here in this corner. Okay, now the only thing left is to put in the hole. So at x equals -5, right there, I'm going to have a hole. So that's a point on the graph that doesn't actually exist. To find that y coordinate, we plug in into the reduced version. So to find the hole, I do k of -5. I can't plug it in here. If I plug it in here, I get 0 over 0. That's why it canceled. I plug in here, and I'll get 2. -5 minus 5 is -10. -5 plus 3 would be -2, so that's -20 over -2, which is +10. So I get a hole at the point -5, 10. It says -20. Okay, so that's the last thing I do. I go back to my graph. So back here at -5, up here, right there, wherever my graph happens to be, I'll come over and say that that is up at 10, and I can even say here -5, 10. Okay, that is the graph of this function. Okay, it's just like graphing all the other ones, only we put the whole one at the end. Okay, that is graphing rational functions. This is a long video, but I wanted to go through a lot of examples. Other videos that are relevant should be popping up now.